Right. So now we look at quadratic equations, right? Quadratic equations, before we start with that, we need to understand the difference between an expression and an equation, right? So we've seen this in the lessons. What's an expression? F of x equals, let's say, x squared minus 5x plus 6, right? An equation is going to be x squared minus 5x plus 6 equals 0, right? Which we can then factor as x minus 2 into x minus 3 equals 0, and we know the values 2 and 3 are what are going to satisfy over here. But when we have a quadratic expression over here, for different inputs, f of 1 is going to give us what? 1 square, which is 1 minus 5 plus a 6, which comes to 2. F of 2 is going to give us a 0. F of 3 is going to give us a 0. We're going to get different outputs over here. 4 is going to give us a 4 square is 16. 16 plus 16 over here um, is 16 plus 6 over here is 22. 22 minus 20 over here is going to give us a 2 again, right? So different inputs, we're going to get different outputs, which we can then plot on a graph, right? A quadratic expression, the graph we'll be looking at soon, right? So just broadly, it's going to be either U-shaped or inverted U-shaped, one of the two only, and we'll look at that as well. Now, what's a polynomial, coefficient, and constant, right? We'll be using these terms over here. Constant simply means the value without a variable. If you have to write a variable next to it, the power is 0, x power 0. Polynomial is something where the variables are going to have integer powers, right? Integer powers, or specifically non-negative integer powers. 0 is allowed, 1 is allowed, 2 is allowed, and so on, right? So those are basically polynomial, coefficient, and constant, right? So theory or basics. Let's move on, right, and get to the next concept over here. Next is the one I was speaking about, which is quadratic expression on a graph, right? So how is that going to look over here? So simple thing, right? So if you're going to have an quadratic expression, the standard way in which we write that is going to be f of x equals ax square plus bx plus c over here, right? The way we're going to be writing it is going to be ax square plus bx plus c, right? Um, there are only two types of curves possible, either U-shaped or inverted U, which is like this, right? This shape. Now, U-shaped is going to be when a is going to be greater than 0, and inverted U-shaped is when a is going to be less than 0. Now, the question is, what if a is equal to 0? Then x square into 0 is 0. Bx plus c is a linear equation, right? It's not quadratic. For it to be quadratic, a is not equal to 0. So, if a is greater than 0, it's going to be U-shaped. If a is less than 0, it's going to be inverted U-shaped, right? That's it. Just that coefficient of x square is going to determine the value, right? So, how is it going to look in terms of an expression, right? And what are the roots of a polynomial, or specifically a quadratic function we'll look at right now? This particular quadratic function over here, what are roots? Roots are x values where my y value is going to become 0. What are the x values where y is going to become 0? Then the roots are going to be those x values, right? X is nothing but input and y is nothing but output, right? Y or f of x, any of these, right? We can write down f of x is also y over here, right? Y axis or f of x axis or output axis. What are the x values or inputs where my output is going to be 0? So in this particular curve, right, what's going to happen at this point, at these x points? So let's say 2 and 3 we have, right? Where x is going to be 2 or 3, my output is becoming 0. At x equals, let us say this is 2.5, what's my output coming to? It can be 2 or whatever, minus 2 or something like that, right? So essentially, we're going to get roots where our expression is going to be cutting the x-axis, and that's it, right? So if it's U-shaped, it has to be cutting this way. It could also be touching it and going, which means how many roots are there? There are 2 roots over here as well. This could be minus 1. There are 2 roots, but both are equal at minus 1, right? That's what it means. If the curve is going to be like this, not touching the x-axis at all, then there are no roots over here. No roots over here. right? And what if it's going to be the other way around, right? So the other way around, if it is going to be touching it over here, it's exactly one root. This could be -5, for instance, right? It could be cutting it at two places. Then there are two roots over there. What if it's simply like this and it's not going to touch the x-axis? There are no roots over here, and that's about it, right? So intersection points with the x-axis tells us about the roots, right? That should give us an idea. More into the discriminant part of it, we'll be looking at soon after a short example, right? Short example. This is something which came up over the recent years, CAT 2020, slot 1. The number of real valued solutions of the equation 2 power x plus 2 power minus x equals to minus of x minus 2 the whole square, right? How do we go about something like this? The left hand side, right? The left hand side is going to be what? 2 power x is an increasing exponential function which is going to be cutting. We've seen that in the logarithm part of it, right? We have discussed the specific thing where it's going to be cutting at 1, right? If x is 0, 2 power 0 is 1. We need to know that. Where if it's 2 power minus x, it's going to be going this way as well. But sum of these two is going to be something like this, right? This where it's going to be hitting the lowest value with x is 0. If x is 0, 2 power 0 plus 2 power 0 comes to 2, right? This is how this graph is going to look. Now, what about the other graph? 2 minus of x minus 2 the whole square, right? We need to get comfortable with this, right? First up, what is, forget 2 minus of and all, what is x minus 2 whole square going to be? X minus 2 whole square is a curve where there are going to be, it's just going to touch the x-axis at 2, right? This is going to be x minus 2 the whole square, because at 2 it becomes 0 and there are two roots, both are 2. It's just about going to touch this and go. The moment you put a minus symbol over here, it's going to get flipped over here, right? Along the x-axis, right? So in the lesson I've said, go through Desmos, right? Make use of that tool, desmos.com, study these curves. It's going to get flipped over here. This becomes minus of x minus 2 the whole square. Next is I have to add 2 to it. If I'm going to add 2 to it, what's going to happen? It's going to be lifted up. It's going to be lifted up, and you're going to get something like this, right? At 2, what is going to be your output over here? It's going to be 2. At 2, it's going to be 2 over here, right? Because you're lifting it by 2, you're adding 2 to it, right? To minus of x minus 2 whole square, if you're adding a 2, you're going to have something like this. Now, if I'm going to draw both on the same, right? So at 0, this becomes 2, the lowest possible value. Now at 2, the highest possible value is going to be 2, right? Now, will these two ever intersect? They will never intersect. They're never going to meet. These two are never going to be equal. So the answer over here is 0 solutions, right? You're asked number of real valued solutions for something like this. The intersection points is what they're asking for the two curves. Left-hand side and right-hand side, they never meet. You can just close it with that and keep going. So the same question, right? A graph is one way of doing it. Let's look at another way as well, right? The left-hand side over here, we can write it as 2 power x plus 1 by 2 power x, right? Right-hand side over here can be written as 2 minus of x minus 2 whole square. What is the minimum possible value of sum of two terms where product is constant? The minimum value over here is going to be when both are equal, right? Both are equal. So, which means 2 power x equals 1 by 2 power x. So, if you multiply, you're going to get 2 power 2x equals 1. And x is therefore going to be 0. Minimum at x equals 0, value equals 1 plus 1, 2. Now in this particular question, from 2, I'm subtracting a square. Subtracting a square, so that square can take a lowest value of 0. The smallest value I subtract over here, I'm going to get the highest possible value, right? So the max is going to be what? The value is going to be a 0. If I subtract, I get a 2. Now for this to be 0, at x equals 2. So if you look at it this way as well and logically look at it and understand that the minimum possible value is 2 and maximum possible value at 2, but at two different inputs, right? They are never going to intersect. It's going to be option 4, 0 over here. So the next concept over here is discriminant of a quadratic expression, and how do we see it from a graph perspective? The discriminant is nothing but b square minus 4ac. I think at this stage, all of you would be knowing that. Now, if your discriminant is going to be greater than 0, then two distinct and real roots, right? So what's your graph going to be like? Your graph is either going to be like this, right? Or anywhere it can be, right? So it doesn't matter. It's going to be cutting at two distinct points, U-shaped or inverted U-shaped as well, is going to be cutting at 2 points. So some part of it is going to be positive and some part negative, right? In both. Now, what if the discriminant is going to be, okay, let's put it this way. What if your discriminant is going to be equal to 0, right? If it's going to be equal to 0, b square minus 4ac equals 0. I think all of you would be pretty much knowing it. It's going to be just about touching over here and touching over here, right? And that's when discriminant is equal to 0. Now, what if discriminant is going to be less than 0? Discriminant is going to be less than 0 if it is not going to be, if it's U-shaped and it's only in the positive zone. If it's negative, if it's inverted U-shaped and it does not touch the x-axis anywhere, right? So therefore, in these cases, your discriminant is going to be less than 0. Okay, so let's look at question 2 over here. Let a be a real number, okay? Then the roots of the equation x square minus 4x minus log a to the base 2 equals 0. Don't be looking at this and trying to factorize it, right? What is the question? Then the roots of this are real and distinct. They are real and distinct. The moment they've told me that it's real and distinct, that means discriminant is greater than 0. If and only if. So discriminant over here should be greater than 0. B square minus 4ac when written in the form ax square plus bx plus c. What is b square? Let's write down the b square minus 4ac. Right? And b square over here, minus 4 whole square, which is 16. Minus 4 into a into c. Minus 4 into 1, minus 4. Minus 4 into minus log a is plus 4 log a to the base 2 is greater than 0. You can write it as log a to the base 2 is greater than minus 16 by 4, minus 16 by 4, which is nothing but minus 4. So a over here has to be greater than 2 power minus 4. A over here has to be greater than 1 by 16 over here. So therefore, the correct answer is option 1. Let m and n be positive integers, right? So if x square plus mx plus 2n equals 0 and x square plus 2nx plus m equals 0 have real roots, both have real roots, then what is the smallest possible value of m and n? M and n, I have to reduce it as much as I can. The moment I'm told that two equations have real roots over here, what can I say? B square minus 4ac for each of them should be greater than or equal to 0. It doesn't say distinct roots, right? Doesn't say distinct. They have real. They can be equal as well. So m square minus 4ac, 4 into 1 into 2n, which is 8n, is going to be greater than or equal to 0. And the next one is going to be 4n square minus 4ac, 4m over here is greater than or equal to 0. And what do we get over here? M square is going to be greater than or equal to 8n and 4n square is going to be greater than or equal to 4n, right? Now m and n have to be positive integers over here, and m plus n, we have to find the smallest possible value. What are the smallest possible values for any one of them? One is possible, right? So just check if n is going to be 1, then m square is going to be greater than or equal to 8, m is going to be greater than or equal to 2 root 2. Then can I say 4 is going to be greater than or equal to 4 into 2 root 2? 4 is greater than or equal to 4 into 2 root 2? No, that doesn't work out, right? That's not helping over here. If you're just looking to quickly, observe and look to substitute, right? We are facing some issues over there, right? Issues over there. N equals 1 doesn't seem to satisfy. Just a bit of a trial, right? So just try out the next possible value over here. And n, if you're going to go for 2, 2 eighths are 16, m can take a value of 4, and try out over here and see as to what's happening. 4 into 2 square is coming to 4 into 2 square over here is coming to 16, and 4 into 4 is also coming to 16, and it works. right? It works over here. So m value of 4 and n of 2, both of these are equal actually, and it's fine. And sum of m4 and 2 over here is going to come to 6, right? And we should be able to close it with that. So next question, suppose k is any integer such that the equation 2x square plus kx plus 5 equals 0 has no real roots. Discriminant over here is less than 0. And the equation this has two distinct real roots. In this case, discriminant is going to be greater than 0 because distinct real roots. Then the number of possible values of k is going to be what? Right. So all that they wanted to do is, you see real roots and all of that, discriminant you have to think of. So first one, discriminant is going to be what? K square b square minus 4 into 2 into 5. 4 2s are 8, 5s are 40. So k square minus 40 is going to be less than 0. K square is going to be less than 40. So in these kind of scenarios, I want you to write down the inequality this way. Root 40 is going to be 6 point something, right? So k over here, they're speaking about integer. It has to be less than 6 point something. The largest possible integer I can have is 6. Greater than, less than equal to 6 is less than equal to, put a minus 6 over here. That's it, right? It's like modulus the way we open it. If modulus of k is less than 10, we can write as minus 10 is less than k is less than 10. Same way for square over here. Once you apply the square root, it's a plus or minus. You open it out this way. Now on to the next part of the equation. This one over here has to have a discriminant greater than 0. So k minus 5 the whole square minus 4 into 1 into 1 minus 4 has to be greater than 0. So k minus 5 whole square has to be greater than 4, right? So greater than 4, we can either directly get to that, right? So which means k minus 5 is less than minus 2, or k minus 5 is greater than 2 over here. If I'm applying square root, it can be plus or minus over here, plus or minus. This term inside should be, again, this 4 over here could be written as 2 square for ease. K minus 5 can be greater than 2, then it satisfies, or k minus 5 over here should be less than minus 2, which satisfies. Instead of multiplying and refactorizing and all of that, you can just go in for something like this and close it out. So k over here has to be less than, take 5 there, and you're going to get 3. And if you take 5 there, you're going to get 2 plus 5, which is 7. Will it be greater than 7 over here? No, I'm not bothered about that. I am looking at less than 3. What are the values which satisfy? Minus k can be less than equal to minus 6, less than 3 over here, right? Less than 3. If you're going to be merging these two, k should be strictly less than 3. So 6, 5, 4, 3 is also not allowed. So only values from minus 6 to 2 is allowed, both inclusive, right? So y minus x plus 1, 2 minus of minus 6 plus 1. That's a total of 9 values which satisfy. So option 4, 9 becomes the answer here, right? Even if you're looking at one inclusive, the other excluded, then y minus x. That's a 3 minus of minus 6, and you get 9, right? So this y minus x plus 1 minus 1, we've been seeing in we saw in the number theory part as well, counting consecutive integers, and you can apply that directly here. On to question 5. Let f of x be a quadratic polynomial in x such that f of x is going to be greater than equal to 0 for all real numbers x. If I'm always going to be greater than equal to 0, I'm not going to get negative at all, right? I'm not going to get negative at all. If I'm always going to be greater than equal to 0, I'm either going to be like this, or I'm going to just about touch and become 0. I'm not going to go below it. That's it. That's the first step. Next, if f of 2 equals 0, that means it is definitely going to be the second graph, because I have a value where my output is becoming 0, right? This is one of the more conceptually heavy questions, but if you understand conceptually, you'll quickly answer. So what is going to be the expression for this particular quadratic polynomial? Here it's going to be f of x equals 2 is the root, and there's only one root, then it's x minus 2 the whole square. If 2 is the root, then x minus 2. X minus 2, the whole square is what it is, but into k, right? We've seen that in the lesson. Through one particular point, one set of roots, there are infinite curves you can draw, right? And because you can multiply the constant k outside. So f of x equals k into x minus 2 the whole square. The moment we write it that way, then it's pretty much done. So f of x equals k into x minus 2 the whole square. F of 4 equals 6. So if this is 4, my output is 6, right? So if x is 4. So if I substitute x equals 4, what am I getting? K into 4 minus 2 the whole square. That's 2 square, which is 4, comes to 6. So I found the k value of 3 by 2. Now the question asked is, what is f of minus 2? Right? Minus 2 is nothing but k, which is now 3 by 2, into x minus 2 the whole square. X is minus 2. Minus 2 minus 2 the whole square. That's 4 square. 16. Divide and you get an 8. And we get a 24. Option 2, 24 becomes the answer here. Heavy conceptual. We need to observe these. F of x is greater than equal to 0, and at one point it becomes 0, right? Otherwise, it's only greater than. That means that one point is the only root. That means there are two roots and both are equal, and it's 2. So x minus 2 whole square. But why am I multiplying with the k? Because that is how it works for a quadratic expression. If you have only 2 points through which you're going to have something, it can be flatter as well, right? There are several ways I can draw symmetrical curves over here. It can be super steep as well. We have seen this, right? You can have several expressions over here. So it's going to be k into these two roots. If this would have been 2 and 3, k into x minus 2 into x minus 3 is the value of the quadratic expression. That's the quadratic expression where roots are 2 and 3. K can be anything, right? That's how it works. That's the same over here, same logic, but x is 2. We have found that it's been given to us. I mean, the root is 2. So k into x minus 2 the whole square. They've told me to substitute 4 and output should be 6. With that, I find the k value. Now k is found. For the next value minus 2, what's going to be? 24. Mark it and keep going. Let's move to concept 5 over here. A quadratic, what's the general form? We just saw it at the start itself, right? F of x equals ax square plus bx plus c, right? Now, what is the roots form and SOR, POR and all of that? Sum of roots, product of roots stuff, right? A roots form in which you can write down this quadratic expression is going to be k into x minus alpha into x minus beta, right? Remember that. And when you expand this, right, what are you going to get? You're going to get kx square minus alpha plus beta into k into x and all of that, right? So you can expand and write it this way. But typically, we observe it from a equation form, right? When it comes to roots and all. If your equation is ax square plus bx plus c equals 0, right? And your roots form is going to be x minus alpha into x minus beta. If you're told that these are the roots, alpha and beta, x minus alpha into x minus beta equals 0 is the roots form of writing it. And when you expand, it can be written as x square minus alpha plus beta into x plus an alpha beta equals 0. That gives rise to the two important things, right? Alpha plus beta is nothing but minus b by a, right? And alpha beta, the product of the roots, is going to be c by a, the constant by the x squared coefficient, right? So these are the bits you need to remember, right? And yeah, so the and yeah, so a couple of other things you could understand over here is your alpha beta should help you understand the sign of the roots as well, right? So if you're going to have something like x square minus 5x plus 6 equals 0, the product of two, the POR over here is positive. The sum of roots is going to be what? Sum of roots over here. Sum of roots is also positive because minus b by a. Minus of minus 5, which is a plus 5. If sum of roots is positive, product of roots is positive, both the roots alpha and beta are going to be positive and positive, right? By observing these two signs, positive, negative, whatever it's going to be. If this would have been negative, then I know one is positive, the other is negative, and so on and so forth, right? You should be able to conclude with those. Okay, so let's look at an example, right? So where we would end up using it. Question 6. The quadratic equation x square plus bx plus c equals 0 has two roots, 4a and 3a, okay, where a is an integer, fine. Which of the following is a possible value of b square plus c? I need to look for a possible value, that's it, okay. When two roots are given and b and c, and around b and c something I'm asked, I need to immediately think of sum of roots and product of roots. What is the sum of roots? 4a plus 3a, which is 7a. And in this case, the sum of roots is going to be equal to minus b by 1, minus b. So which means b equals minus 7a. What about the product of roots? 4 into 3, 12. A into a is a square equals c by 1, right? C by a or c by 1. So c equals 12a square, right? That's it. So let me just rewrite it this way. Now, which of these is a possible value of b square plus c? What is b square plus c going to be in terms of a? B square, right? Minus 7a the whole square, which is 49a square plus 12a square as it is. And that's going to come to 61a square. So which of the following is a possible value where a is an integer? If a is an integer, I need to get a 61 times a perfect square, right? An integer square. Where am I getting a 61 times an integer square? Take the 549. Is it divisible by 61? If I divide, I'm getting a 9, right? 61 into 3 square, right? That seems fine over there. That seems fine over there. So 549 seems to satisfy. You can just mark that and keep going. 361 over here is a 19 square, right? The table. So that's not going to be a 61 multiple. 427 over here is, yes, 61 into 7, but 7 is not in the a square format, right? The moment you find the first one, closer to that and keep going, right? That should be the approach over here. Let's take up another one. The knowing the roots over here is what is going to be helpful, right? So the next concept, let me just give you an overview, and then we look at question 7, just in case some of you wouldn't be knowing. So if ax square plus bx plus c equals 0 over here, right? Ax square plus bx plus c equals 0. Then x equals minus b plus or minus root of b square minus 4ac by 2a. And this is something which all of you should be knowing by now, right? We're looking at revision. So in this particular one, right, if a, b, and c are rational numbers or integers or anything like that, then we are getting two parts over here, which is minus b by 2a plus or minus root of b square minus 4ac divided by 2a, right? If a, b, and c are going to be rational numbers, this is going to be a rational number. This is going to be the irrational number, right? Which simply means if one root over here is 2 plus a root 3, the other root is going to be 2 minus root 3, right? It's a rational number plus or minus an irrational number. If one is 2 plus the irrational number, the other is 2 minus the irrational number, right? We would be able to find the second root this way, provided all three a, b, and c are rational numbers, right? That's the logic, right? So given the backdrop, right, what do we have over here? Suppose one of the roots of the equation ax square minus bx plus c equals 0. I put a minus here, is 2 plus root 3, where a, b, and c are rational numbers. Immediately I can say the other root over here is going to be 2 minus root 3. That's my second root over here. And what can I say about my sum of roots? Sum of roots is minus of minus b, it's a plus b, b by a, and that comes to sum of these two. 2 plus root 3 plus 2 minus root 3. Root 3 cancelled, you get a 4. So I can say b equals 4a. Now what about the product of roots, which is c by a. Product of roots equals c by a, and that is going to be, product of these two is going to be a plus b into a minus b format is a square minus b square. A square is 4 minus b square, root 3 the whole square is 3. So which is just 1. So therefore c, I can say, is going to be equal to a over here. All right. So b is 4a, c is a. Now what have I been told? B is equal to c cube. B is equal to c cube. So 4a over here equals a cube. right? So then if I just bring 4a to one side, a cube minus 4a equals 0. A into a square minus 4 equals 0. A square minus 4 is a plus 2 into a minus 2 equals 0. So what's going to be the value of a is not equal to 0, right? So therefore, in fact, if a is not equal to 0, I could just simplify it over here itself and said a square is 4, a equals plus or minus 2, right? If a is plus or minus 2, both cases, we're going to be getting option 3, 2 over here. We're getting the same values here. A is 0 or 2 or minus 2. 0 it can't be. It's clearly given, right? Because it's quadratic. So 2 or minus 2. Modulus of 2 or minus 2 is going to give us just 2. Question 8. Very similar to the previous one because a, b, c, m and n are integers. If 3 plus 2 root 2 is a root of this and 4 plus 2 root 3 is a root of the next one, then what is the value of b by m plus c minus 2b by n? Right? Okay, it looks a little complex, but what are we going to get? Right? So m and n are from this particular one. Okay, b and c are from the first one, and a over here is common. Okay, you can just find the sum of roots and product of roots. The sum of roots for the first one, let's take the first one, 3 plus 2 root 2 and 3 minus 2 root 2, right? SOR, sum of roots is 6. POR is going to be product of these two, 3 square minus 2 root 2 the whole square. 3 square is 9, 2 root 2 the whole square is 8, so that's 1. And once again, why do we take it this way? If all of these are going to be integers, minus b plus or minus root of b square minus 4ac by 2a, right? It's a plus or minus for that's where the irrational part is going to come. If one root is 3 plus 2 root 2, the other root is 3 minus 2 root 2, the opposite sign. And that's it, right? So 6 and 1 over here. Eventually, there's going to be only one answer. You can just form the equation as x square minus 6x plus 1 equal to 0. Take the next one and see as to what you're getting, right? So 4 plus 2 root 3 and 4 minus 2 root 3. The sum of roots over here is going to be 8. The product of roots over here is going to be 4 plus 2 root 3 into 4 minus 2 root 3. So 4 square is 16 minus 2 root 3. The 2 root 3 the whole square, that comes to 12 and it comes to 4 over here. So this is going to be y square minus 8y plus 4 equals 0. Now the condition for the 2 is the x square's coefficient should be the same as a. Should be the same. It's a in both cases. X square and y square coefficient. And over here, x square and y square both have a coefficient of 1. It's fine. Satisfies. That's it. So b is minus 6. C over here is 1. And m over here is going to be minus 8. And n over here is going to be 4. All right. Plug in over here and see what the value is. B by m, minus 6 by minus 8, which is 3 by 4. Minus and minus are cancelled. Plus c minus 2b, 1 minus of minus 6, or minus 2, 1 minus 2 into minus 6. That's a 1 plus 12, 13 divided by n. N over here is just 4. This is what we have to find. 3 plus 13 is 16 by 4, which comes to 4. Option 4 becomes the answer here. So very quickly on to solving quadratic equations, all right? So if you're going to be given something like x square minus 5x plus 6 equals 0, right? I need to multiply 1 and 6, all right? And write the product as 6. The sum over here is how much? Minus 5. How do I split minus 5 into 2 parts such that the product is 6? Minus 2 and minus 3. So my roots are going to be minus 2 and minus 3, I will write. Next step is change the sign. Last step is divide by the coefficient of x square, which is 1. So my roots are 2 and 3, right? Some of you will think that, hey, why not just write it as x square minus 2x minus 3x plus 6? Here it's not taking too long. X into x minus 2 minus 3 into x minus 2 equals 0, and you get x minus 3 into x minus 2. Yeah, that's correct. But if you look to write it this way, you're going to skip a few steps. We can take up an example, another one, 3x square. 3x square plus, let's make this 16, right? Plus 16 over here, or minus 16 over here, we can have. And we could have a plus, could be yeah, 2x, right? 2x over here, right? So if this has to be factorized, what do? I will write the product over here as a into c, 3 into minus 6, which is minus 48, and the sum over here has to be plus 2. So 2 has to be broken down to two parts such that one is positive, one is negative, because product is negative. What is going to give me 48? 8 into 6, difference is 2, makes sense. So my x values are going to be, for the sum to be 2, it's going to be 8 and minus 6, right? These two add up to 2. 8 and minus 6 get multiplied to get minus 48, works out. So first write 8 and minus 6. It's the first step. Next step is to change the signs over here. What is plus becomes minus, and what is minus becomes plus. Last step is divide by the coefficient of x square, and that's 3. And we quickly get minus 8 by 3 and 2. That's the two values, two roots over here, right? So if you wanted to do it the other way, it would have been 3x square, you split it up, plus 8x minus 6x minus 16 equals 0. Take a x common, 3x plus 8, and then a minus 6, minus 2 common, and you get a 3x plus 8 equals 0. And x minus 2 into 3x plus 8. A lot of steps over here to get to 2 and minus 8 by 3, right? Which is what we got here. So you can just be a little quicker if you factorize. I mean, split it up this way, write down the two values, switch the signs, and divide by the x square's coefficient, right? So that's one way to solve the quadratic equations. A second way is where ax square plus bx plus c equals 0. X can be written as minus b plus or minus root of b square minus 4ac by 2a, which is what we saw, where you're going to be given roots in terms of a surd, where one of the roots is 4 minus root 3, where a, b, and c are rational numbers. The other root is going to be 4 plus root 3. That's it, right? Just do it that way and close it out, right? The third method is going to be completion of squares, and completion of squares is something I don't want to touch upon right now, that you wouldn't be using to solve quadratic equations much. If you want, you can refer to the lesson or the concept video, right? Speed concepts. You can refer to it over there, right? So let's look at solving a couple of quadratic equations, right? So questions like these: x plus 1 is equal to x square, and x is greater than 0. Then 2x power 4 is going to be what, right? Nothing. All they're doing, asking you to do, is solve for it. Find the root which is x is greater than 0, right? Find the root which is going to be greater than 0. So x plus 1 is x square, then x square minus x minus 1 is equal to 0. If this is the case, what can be the two roots? X equals minus b, minus of minus 1, it's a plus 1, plus or minus root of b square minus 4ac. Minus 4 into 1 into minus 1 is a plus 4, divided by 2a. So my roots are going to be 1 plus root 5 by 2, or 1 minus root 5 by 2. Now 1 minus root 5 is more than 2, right? 1 minus root 5 is going to be negative, but x is given as greater than 0. So this is not what we want. It's only this. We need to find the value of 2 into x power 4. What is x square going to be? When I square this, my denominator becomes a 4. 1 plus root 5 whole square is a square plus b square plus 2ab. 1 plus 5 plus 2 root 5. So that's a 6 plus 2 root 5 by 4. If I take a 2 common, it's 3 plus root 5 by 4. And we get a 2 here. What is x power 4 going to be over here? This entire thing whole square. So I get it divided by 4. A square plus b square. 9 plus 5 plus 2 into 3 into root 5. 6 root 5. Now 14 plus 6 root 5, I take a 2 common. I get a 7 plus 3 root 5. Divide by 4. And we get 2 here. X power 4 is this. 2x power 4 is nothing but into 2. If I multiply over here, this cancels and you just get 7 plus 3 root 5 is the answer over here, right? 7 plus 3 root 5 is the answer, and so it was, yeah, option 4 is the answer here. So on to a different type of question over here, right? Question 10. This is not like a standard type of quadratic. We have two variables over here, something which much bigger powers, right? 2018, 2017, all of that. But what do we note over here? X power 2018 into Y power 2017 is half. X power 2016 into Y power 2019 is 8 over here. What I can conclude with this is that one is going to be the reciprocal of the other. With super high powers, right? Super high powers, I'm getting half and 8. Then what are the classic reciprocals possible? One is 2, the other is half. That should be the first thought process. X square plus Y cube is what I have to find, right? So which is 2, which is half, we have to see. X power 2018, Y power 2017 is nothing but xy to the power of 2017 into x is coming to 1 by 2. The second one, x power 2016 into y power 2016, xy to the power of 2016 into y cube is coming to 8. From this itself, if one is reciprocal of the other, what can I say over here? Xy is going to become 1, then x is half, meaning y should become the reciprocal 2. Does that make sense? If y is 2, 2 cube 8 makes sense, right? You can just observe that and close it out because x square plus y cube is such small numbers, right? So x square plus y cube over here is going to be 1 by 4 plus y cube is going to be 2 cube 8. Take the LCM and you get 33 by 4. Option 3 becomes the answer here. So on to the next question. Looks like a quadratic equation over here. What do we have? We have u square plus u minus 2v minus 1 the whole square. It's one huge thing. And something over here, then what is the value of u plus 3v, right? Now u minus 2v minus 1 the whole square, I don't want to expand. I want to keep it as it is. I'm getting a minus over here, right? What is this giving us? It is minus 4 uv plus, or rather minus 4 v square. What if I take it to that side and merge it with u square? What am I getting? U square plus 4 uv plus 4v square plus u minus 2v minus 1 the whole square equals 0, right? I've brought it to this side over here. Now what is this like? If this is it in the form of u plus 2v the whole square expansion? U square plus 4v square plus 2 into u into 2v plus 4uv works out, right? So plus u minus 2v minus 1 whole square equals 0. That's it. U plus 2v. I mean, how is this possible? Sum of two squares can be 0, right? Squares are never going to be negative. If sum of two squares is going to be 0, it's only possible if each of these values is 0. That is u plus 2v equals 0 and u minus 2v minus 1 equals 0. Both have to be equal to 0. We need to solve for the values of u and v and plug into this u plus 3v. So what do we get here? We'll just keep it as this, u plus 2v equals 0. In fact, we can just add the two of them, right, over here itself. The moment we got these, if we just add the two of them, we're going to get 2u, 2v minus 2v cancelled, minus 1 equals 0, u equals half, and what is the v value going to be? If I'm going to plug in over here, plug into this over here, if u is half, 2v equals minus half and v equals minus 1 by 4, right? What is u plus 3v going to be? Half plus 3 times minus 1 by 4, which is minus 3 by 4. You take the LCM, is going to be 2 minus 3, which is minus 1 by 4 over here. So the answer becomes option 1, minus 1 by 4. So next up, what do we have here? The number of solutions to the equation modulus of x into 6x square plus 1 equals 5x square is going to be what? The number of solutions I want over here. The moment I see this to be an x multiple, this is also an x multiple, I can say straight away x equals 0 is a solution, right? 0 into something, 0 into 5. They're equal. I can write that down. Now, given that there's a modulus involved, although we'll be looking at inequalities in detail, we know that the modulus can be expanded this way. Two scenarios, x is greater than 0, right? Then what is that going to become? That is going to be x itself. X into 6x square plus 1 equals 5x square. Now, if x is going to be less than 0, then what is it going to be? Then it's going to come up as minus x into 6x square plus 1 equals 5x square, right? Two scenarios. Now, given that I've identified x equals 0, I can cancel out an x on both sides, right? If it's confusing, don't worry. Just write it down this way. 6, you don't need to cancel also. Write it down as 6x cube plus an x. But if I bring the minus 5x square, 5x square becomes that plus an x equals 0. I can write it as x into 6x square minus 5x plus 1 equals 0. And what are the values of, x can be 0, which is identified already. And this particular expression over here, sum is minus 5, product is 6. So minus 2 and minus 3. They add up to minus 5 and product is 6. Switch the signs. Divide by 6. 2 by 6 and 3 by 6, are they greater than 0? Yes, they are. Both are fine. Okay, 0 is already identified with a tick. I'll leave it at that. This particular one, given that we had identified x equals 0, I can cancel x on both sides. Let's see how to do this. 6x square plus 1 you take to that side, you're going to get 6x square plus 5x plus 1 equals 0. And x values are going to be, break it as 2 and 3. 2 plus 3 is 5. 2 into 3 is 6. Switch the signs and divide by x square's coefficient. These are the roots here. Both of these are negative. That is also fine. So what is the total number of solutions for this equation? These two and this one over here, total of 5. That's the answer here. Question 13. The product of the distinct roots of modulus of x square minus x minus 6 equals x plus 2, right? Equals x plus 2 over here. Just see if you can factorize this, right? If you can factorize this, you can, right? So it's going to be x minus 3 into x plus 2, right? If you factorize this, minus 3 plus 2 is minus 1, minus 3 into 2 is minus 6 over here. So that's modulus of this equals x plus 2 over here, right? How is this going to be? When is it going to be less than 0 or more than 0? So we know that actually this is something we'll be seeing in inequalities lesson, right? Just refer to that part in case you're not clear. But those of you who have gone through the inequalities lesson, you'd know that number line we draw and we have a minus 2 and a plus 3 over here, correct? Now it's going to be positive in the rightmost region, negative over here and positive over here, right? Positive in the rightmost region, negative over here and positive over here. That's it, right? Where it's going to be positive, it's just going to expand this way, open up this way. X minus 3 into x plus 2 equals x plus 2, right? Where it's negative, it's going to open up as minus of x minus 3 into x plus 2 equals x plus 2, right? X plus 2 is cancelled means if it is cancelling, if I'm going to be cancelling on both sides, what is that one thing I need to note down? There is a possible solution where x is minus 2, right? If x plus 2 is going to be 0, 0 into something equals 0, I can't cancel 0 on both sides, right? So that's an issue. So therefore, whenever I'm going to be cancelling, I have to identify that as a possible solution. X equals minus 2 over here is a possible, is one of the roots. Now you can go ahead and say x minus 3 equals to the minus 1 there, x equals move this here and you get a 2, right? Is x equals 2 in this region? Yes, it is. What about this particular one? X minus 3 into, again, this common, and x equals, take the 3 there, 3 plus 1 becomes 4. Is 4 in the positive region? It is. Then what is the product of all the distinct roots? Your minus 2, your plus 2, and a plus 4. 4 to 2, 4 into 2 into 2 is 16. A minus is there. So option 2, minus 16 becomes the answer. So 14th question, what is the largest positive integer n such that n square plus 7n plus 12 divided by n square minus n minus 12 is also a positive integer? That should also be a positive integer. Can I factorize these? Looks like, right? N plus 3 into n plus 4, the first one. And what about the bottom one? N minus 4 into n plus 3, right? N minus 4 into n plus 3 over here. Now, what is the largest positive integer which n can take? N can take such that this is also a positive integer. That means numerator should be divisible by the denominator. That's it. I mean, whatever is divisible, you can divide straight up. We're not equating it to 0 and all of that. I'm not cancelling n plus 3 on two different sides of the equation. It's an expression, divide it. N plus 4 divided by n minus 4. When is it going to be the largest possible value? I mean, largest positive integer n which satisfies this. Start with the largest 16. Is 16 plus 4 by 16 minus 4? 12. Is 20 divisible by 12? No. Next possible value 12. 12 plus 4 divided by 12 minus 4. Yes, divisible. Mark that. Keep going. On to question 15. How many distinct positive integer valued solutions exist to this equation where some quadratic expression to the power of another quadratic expression equals 1? Right? First step for you to understand is, when are you going to get 1? There are 3 scenarios where you can get 1. People typically think of 2 scenarios. The first scenario is 1 power x is always 1 power whatever. Let me write it as k equals 1. The other is k to the power of 0, right? What k is any value it can take. K power 0 is always equal to 1. Then there's this third scenario, which is minus 1 to the power of k is also equal to 1 when k is even, right? K is even. That's the last one we need to remember, right? So when is k going to be even, all of that, right? So that we'll look at now. Now, quickly, the base over here should be 1. If x square minus 7x plus 11 is 1, then what are we going to get as roots? If it's equal to minus 1, what are we getting and all of that? But power is 0. If the power is 0, what's going to happen, right? We'll look at that. Now, the question asked over here is, how many distinct positive integer valued solutions exist, right? Distinct positive integer valued solutions exist for x. That's like a very loaded question over here, right? Let's start with the base being equal to 1, right? Case 1, case 1, case 2, and case 3 over here. Starting with case 1, if the base is equal to 1, x square minus 7x plus 11 equals 1, then x square minus 7x plus 10 equals 0, x minus 2 into x minus 5 equals 0, x equals 2 comma 5, both are acceptable positive integer value solutions. Case 2 over here is going to be when the power is equal to 0. The power is equal to 0, then x square minus 13x plus 42 equals 0. How do I split it? Minus 6 in x minus 6 into x minus 7. 6 plus 7 is 13, right? 42. X can take the values of 6 or 7 as well. 2 more, right? Distinct positive integers, 6 and 7. The third scenario over here where the base is equal to minus 1. So x square minus 7x plus 11 equals minus 1. Bring the minus 1 here. X square minus 7x plus 12 equals 0. X minus 3 into x minus 4 equals 0. X can take the values of 3 and 4. But hold on. If it takes the values of 3 or 4, the power should be even. What was the power over here? The power we had factorized as x minus 6 into x minus 7. Actually, we know that if one is even, the other is odd, right? The other number is 1 less than this. That's it. We know that whatever integer you're going to put, it's going to work. One is even, one is odd. Product of an even odd number is even only. So it's fine. If you want, you can substitute 3 into, 3 you substitute over here. So you're getting minus 3 into minus 4. If you put 4 over here, you're getting a minus 2 into minus 3. In both cases, it's going to be even. It being negative is fine. It's going to become 1 by. It's still going to satisfy. So that's perfectly fine. So therefore, there are 1, 2, 3, 4, and 5, 6, 3 and 4. So 2, 3, 4, 5, 6, 7. Those are the values, 6 distinct positive integer valued solutions for this. And something similar to this came up in 2022 slot 2 as well, last year's paper, right? A lot of questions similar to this. Yeah, so it tends to repeat, right? It's just a pattern, that's it. It's not like, the same questions are turning up. So yeah, so question 16 from the next slot of the same year. The number of integers that satisfy the inequality, x square minus 5x plus 7 whole power x plus 1 equals 1, right? Again, 3 scenarios. The first scenario is going to be where the base over here is 1, right? So case 1 is where x square minus 5x plus 7 equals 1. Then x square minus 5x plus 6 equals 0. You should be knowing that, this gets factorized as x minus 2 into x minus 3. X is 2 comma 3. Both are integers. Doesn't say positive, right? It says number of integers. So 2 and 3. Next, what if the power is going to be 0? That is case 2, which is x plus 1 equals 0. Then x equals minus 1, right? So that's another one. We've identified another one. Now, what about the third one, which is the base is equal to minus 1, case 3, right? X square minus 5x plus 7 equals minus 1, where the power is even. Power is what? X plus 1. So here, if I bring minus 1 to this side, x square minus 5x, it's going to become a plus 8 equals 0, right? Yeah. So how do I factorize this? 8 is 2 and 4, 1 and 8. None of that is working out over here. You are going to get some value of x, but it's going to be a surd. It's not going to be an integer. So we stop it at this. 1, 2, and 3 values satisfy. Option 3 over here becomes the answer. Now consider the pair of equations x square minus xy minus x equals 22. Y square minus xy plus y equals 34. Then x minus y equals what? X minus y equals what? What if I subtract these two? I'm going to get x square minus y square, or y square minus x square, and then I'm getting y plus x. Okay, that's one way. What if I add these two? Then this is minus x plus y. Okay, and this is going to be x square plus y square minus 2xy, which is like x minus y the whole square. In both cases, I'm getting x minus y types, right? That's an observation to make. If you subtract, xy gets cancelled, great. But you're getting y square minus x square and y minus x. You take a y minus x common, you're getting a y plus x plus 1. How do you go around that? As against adding the two up and see as to what's happening. If I add these two equations, I'm getting x square plus y square minus 2xy. Then a minus x plus y, right? Minus x plus y equals 22 plus 34, which is coming to 56. Now, x is greater than y. Okay, x is greater than y. How do I write this? I can write this as x minus y the whole square, right? Minus of x minus y equals 56. If I take an x minus y common, I'm going to get a x minus y minus 1, right, equals 56. But wait, x is greater than y. Yeah, so this is fine, right? And x minus y, correct. Yeah, so it's fine so far. So x minus y into x minus y minus 1, something into something minus 1. 56 can be, what are the closest possible numbers? It's going to be 8 into 7. So x minus y is like 8, then x minus y minus 1. From whatever 8 is there, subtract 1, you get a 7. 8 into 7 is 56. So x minus y over here equals 8. Option 3 becomes the answer here. Question 18, let a and b be natural numbers if a square plus ab plus a equals 14, b square plus ab plus b equals 28. Then 2a plus b equals what? Looks very similar to the previous question. The difference being that, let's see, let's add the two of them, and what are we getting? A square plus ab plus b plus ab plus b square. That's a square plus 2ab plus b square plus a plus b equals 14 plus 28, 42, right? And what are we going to get? A plus b the whole square plus a plus b equals 42. You can try in integer values if you want. 6 square plus 6 is 42, right? That itself will give us a plus b equals 6. Is working out over here. Now, what if I'm going to subtract over here? Subtract these two. The right hand side minus left hand side. I'm getting b square minus a square. ab and ab are cancelled, plus b minus a equals 28 minus 14, which comes to 14. B minus a is going to be uh, b minus a into b plus a plus b minus a equals 14. Take a b minus a common, we get a b plus a plus 1 equals 14. But I just found b plus a, that's 6. Then b plus a plus 1 is going to be 7. B minus a into 7 equals 14, and you get 2. B plus a is 6. B minus a is 2. Add the 2, you get 2b equals 8, and b equals 4. And a over here is going to be 2. What is 2a plus b? 2 times 2, which is 4, plus b, which is 4. And we get the value of 8. Option 2 over here becomes the answer. Concept 7 now, a little quickly with this concept. New equation when k is added, right? So we have seen this. If ax square plus bx plus c equals 0, right? Questions haven't really turned up around this, but nevertheless, we should know. It's a simple concept, right? So ax square plus bx plus c equals 0 is an equation where alpha and beta are the roots. Then the equation where alpha plus k and beta plus k are the roots. What is that equation going to be? A into x minus k the whole square plus b into x minus k plus c equals 0. Wherever I have x, I'm going to replace it with x minus k. If it's plus k, I replace with minus k. If it would have been alpha minus k and beta minus k, then we're going to replace it with x plus k, right? And that's it. If it would have been alpha into k and beta into k, the opposite is going to happen. A into x by k the whole square plus b into x by k the, right, k the, plus c equals 0. And if this would have been divided by k, then this is going to be multiplied with k, right? So that's the concept over here. Simple thing, not anything in the recent years, but if something turns up, you should be able to apply. Now, the last part over here is what if the roots are going to become the reciprocal? If ax square plus bx plus c equals 0, for that the roots are alpha and beta, where it's reciprocal, it's simply cx square plus bx plus a equals 0. That's it. So a ratio of roots formula over here, right, where ax square plus bx plus c equals 0, right, that's the general form of the quadratic equation, has roots in the ratio of p is to q, right? Then b square pq equals ac into p plus q the whole square, right? So that's going to be the equation where p and q are the terms of the ratio. That's b square pq equals ac into p plus q the whole square. Question is turned up around this in IAFT, right? So one root of the equation ax square plus bx plus c equals 0 is double of the other. That means 2 is to 1. That's my p and that's my q. General form A, B, C are used. then 2b square equals what? B square PQ equals AC into the P plus Q the whole square. So B square into 2 into 1, which is 2b square, equals AC into P plus Q, 2 plus 1, which is 3 square, which comes to 9AC, right? 9AC. That's the value of 2b square. 2b square over here equals 9AC. So very quickly, on to binomial identities, right? We'll just take it up with an example. This is a lesson example itself, right? Something around this hasn't come up in the recent past, but it can, right? So if alpha and beta are the roots of the equation x square plus 5x minus 3 equals 0, what is the equation whose roots are 1 by alpha square and 1 by beta square, right? So when we have this, we need to note down that the sum of roots, which is alpha plus beta in the first one, is minus b by a, minus 5 by 1, which is minus 5. And what is alpha beta? That's the product of roots. That's c by a, which is minus 3 by 1, right? Which is minus 3. Now, I need to find a new equation where the new sum of roots is 1 by alpha square plus 1 by beta square, because those are the two new roots. So if you take the LCM, you're going to get alpha square plus beta square divided by alpha beta the whole square. Alpha square plus beta square is alpha plus beta the whole square minus 2 alpha beta. This is how we write it. A plus b whole square minus 2ab for a square plus b square. The reason we write it this way is so that we have everything written as sum of roots alpha plus beta or alpha beta. Now alpha plus beta the whole square is minus 5 the whole square, which is 25, minus 2 into alpha beta. Minus 2 into minus 3 is a plus 6 divided by alpha beta the whole square. Minus 3 the whole square is going to be 9. So we're getting 31 by 9. Now what about the product of roots? The new product of roots, 1 by alpha square into beta square, which is 1 by alpha beta the whole square. Alpha beta is minus 3, so that's going to give us 1 by 9. That's it. So what's the new equation? X square minus of sum of roots 31 by 9 into x plus product of roots equals 0. Take the LCM and throw the 9 out. We're going to get 9x square minus 31x plus 1 equals 0, and that comes to option 3 over here. So the next concept is on common roots over here, right? So what are common roots? We could be given two quadratic expressions, and we might be asked to find the number of common roots. So if I have two quadratic expressions, they could intersect at one point, or the two of them might never intersect, or they could intersect at 2 points. Now, if these are going to be a common root, right, then it should be like this, right? The two expressions are intersecting when the output is 0, right? So that's what a common root means over here. And we have to first equate the two expressions, find the intersection points, and then check if those intersection points are going to give us 0 as the output, right? That's the approach. So something around this turned up over here, right? A few years back, quite a while back actually, right? So let's look at this. The number of roots common between two equations, x cubed plus 3x squared plus 4x plus 5 equals 0 and one more, is how many, right? Which means I have to equate these two. They're not quadratic, but nevertheless equate them to find the intersection points. So x cubed plus 3x squared plus 4x plus 5 equals this. So 7x plus 3. X cube is cancelled. Bring the 2x square. It's x square minus 3x plus 2 equals 0. It's minus x minus 2 into x minus 1 equals 0. X equals 1 and x equals 2 are the intersection points of these two. For any of these values, is the output going to be 0? That's what the question is. For the expressions, they're going to be meeting there. Is for 1 or 2, am I going to get an output of 0? If one of them is also 0, the other is also going to be 0 because they're intersection points. But what do I notice over here? All the coefficients are all positive. So if I put 1 inside, I'm going to get a positive number. If I put 2 inside also, I'm going to get a positive number. No negative signs here. So therefore, it's not going to be equal to 0 if I substitute 1 or 2. So I have two intersection points, but none of them are common roots. Answer is 0 here. Next up, we'll straight get into a question over here, right? Around infinite series. This is again from a lesson example, right? So how do we work with something like this in solver, right? So what do we have? We have something recurring, root of 15 minus 2 into root of 15 minus 2 into root of, so it continues over here. So x equals root of 15 minus 2 into, the moment I repeat this root of 15 minus is from here. So from here onwards, it's the same as what I had from the start. From here onwards, whatever I'm getting is the value of x. I can put an x over there, right, in an infinite series. Square both sides. X square equals 15 minus 2x. Bring the stuff here. X square plus 2x minus 15 equals 0. X plus 5 into x minus 3 equals 0. So x can be 3 or minus 5. Look at the question for conditions. X has to be greater than 0. So x equals 3 is the answer. This can't be the answer here. Then another type which hasn't really come in the recent past, right? Another type which hasn't come in the recent past, a lesson example. I should be knowing though. For how many integral values of x is x plus 1 by 2x minus 1 minus 10 times this equals minus 3, right? Now a question like this, how do we go about it, right? So quickly, we need to observe the pattern over here. One is the reciprocal of the other, right? So therefore, let y be equal to x plus 1 divided by 2x minus 1. Then this is nothing but y minus 10 times 1 by y, reciprocal, right? 10 times 1 by y is 10 by y equals minus 3. Then we're getting y square minus 10 divided by y. Put the y there and you get a minus 3y. Bring it here, you get y square plus 3y minus 10 equals 0. Y plus 5 into y minus 2 equals 0. So y over here can be 2 or minus 5. So try out the first value, see if you're getting an integer value for x. So if x plus 1 by 2x minus 1 equals 2, right? Then what are we getting? X plus 1 equals 4x minus 2. You get 3x equals 3. All right. Yeah. X equals 1 satisfies. You're getting an integer value there. The next one, x plus 1 by 2x minus 1 equals minus 5. What are we getting here? X plus 1 equals minus 10x plus 5. Continue here. 11x equals 4. X equals 4 by 11. No, it's not integer. So the answer is 1. Only one integer value is there for x. So remainder theorem and synthetic division, we'll look at it with an example itself, right? So, I mean, this is something which came in the FMS paper, right? 2010. If we have 3x cubed minus 9x squared plus kx minus 12 is divisible by this, then it is also divisible by what? Okay. If this is divisible by x minus 3, then I can apply remainder theorem to find out the value of k first, right? Then I can apply synthetic division to divide by it and find the factors. So how do we find this? K over here, right? So if f of x is divisible by x minus k, right? Then if this is the case, x minus k is a factor, then f of k is equal to 0 for sure. There's no remainder. It's perfectly divisible. So if I substitute that root, I'm going to get 0 over here, right? 3 over here is the root. So therefore, in this, if I substitute 3, what am I getting? F of 3. If this is f of x, f of 3 is going to be 3 into 3 cube, 81, minus 9 into 3 square, 81, plus k into 3, 3k minus 12 equals 0. Then we get k equals 12 by 3, which is 4, right? So we have found the expression f of x equals 3x cube minus 9x square plus 4x minus 12. The moment we found this, then we can apply synthetic over here. Write down 3 minus 9, 4 minus 12. That's the procedure. And 3 over here was the root. So put a 0, add it up, you get a 3. 3 into 3 is going to be 9. And you add it up, you get a 0. And then 3 into 0 is a 0. You add it up, you're going to get a 4. 3 into 4 is 12. You add it up, you get a 0. That was the reason, right? So once you divide by x minus 3, you're going to get x square, x and constant, right? So which simply means when factorized, it's x minus 3 into 3x square plus 0x, okay, 0 plus 4. That's the constant, right? And that's it, right? So this is x bar 0. So if this is divisible by x minus 3, then it's also divisible by 3x square plus 4. So the answer over here becomes option 2. Now, how do you factorize cubic and biquadratic equations? The same way, right? You have to, cubic and biquadratic, you have to try out some values. You plug in a value of x equals 1, x equals 2, minus 1, and see if at any of these points it's becoming output is 0. If it does, then apply synthetic division to then bring it to a quadratic form and factorize, right? That's the only way. Other than that, no big shortcut or anything like that. But a few things for you to note when it comes to cubic, biquadratic and all of that, right? So if you have ax cube plus bx square plus cx plus d equals 0, the sum of roots is always minus b by a. Sum of roots 2 at a time. Alpha beta plus beta gamma, gamma, something like this, plus gamma alpha, right? Forget the sign, equals c by a. It's going to alternate. And product of roots, which is alpha, beta, and gamma, which is going to be minus d by a over here. All right. Sum of roots is always minus b by a. Product of roots changes depending on the number of roots. If it's odd number of roots, it's a minus, right? Because x minus alpha into x minus beta into x minus gamma, right? If you multiply the constants, minus alpha, minus beta, minus gamma, it's going to be sitting with a minus sign. So it's minus d by a, alpha, beta, and gamma if you multiply the 3 roots. Now, what about biquadratic, where it's power 4, ax power 4 plus bx cube plus cx square plus dx plus e. The sum of roots is always minus b by a everywhere, right? Here it's 4 roots. So product of roots is going to be a plus e by a, the last one. And it's going to keep alternating, c by a and minus d by a. What is it? 2 at a time when you multiply, and 3 at a time, which is alpha, beta, gamma delta, gamma delta alpha, and all of that. All right. Where if you're going to add those up, you're going to get these values. All right. I'm not going to touch upon this too much. It's there in the content, the concept videos, and all of that. You can look into it for details. All right. The speed concepts part. But it's something directly around this has not really, has turned up around the important parts, which is minus b by a and e by a, right? Sum and product, but not around the middle terms and all of that. So therefore, you can just refer to it to have a full understanding. But yeah, let's take up an example, right? That's more important. Something which has been more conceptual in CAT 2020 slot 1. In this question, we have f of 5 plus x equals f of 5 minus x for every real x, okay? F of x equals 0 has 4 distinct real roots. Okay? 4 distinct real roots. Then the sum of these roots is going to be what? Now look at it from a quadratic perspective. What do we know? Along the point where it's going to attain minimum, right? For a U-shaped curve, it's going to be symmetrical on the left and right. So they're going to be, if one root is minus b plus something, the other is minus b minus root of b square minus 4ac by 2a, right? Plus a constant minus constant. So that's how it works. Now, what do we have over here? So let us say the four distinct real roots are going to be, if one of them is going to be 5 plus a, I can put any value over here. If f of 5 plus a is 0, then f of 5 minus a is also 0. Then 5 minus a becomes the other root, right? Likewise, if one of the roots is going to be 5 plus b, then the other root is going to become 5 minus b, right? Four distinct real roots. That's it. So these are the four roots over here. What is going to be the sum of these roots? If I add all of these up, a and a are cancelled, b and b are cancelled. I get 5 plus 5 plus 5 plus 5, which comes to 20. Option 4, 20 becomes the answer here. Let's take up another question. A recent paper, right? Something which I've written. Let R and C be real numbers. R and minus R are the roots of this. Okay. Then C equals what? Right? If R and minus R are roots over here, that's it. Plug in R. What are you getting? 5R cube plus C R square and all. If you plug in minus R, it's becoming minus 5R cube, right? So put in R over here, you get 5R cube plus CR square minus 10R plus 9 equals, if you put minus R, it's minus 5R cube. Minus R whole square is R square only plus CR square. Minus 10 into minus R is plus 10R. And then a plus 9, right? So plus 9 is cancelled. CR square is cancelled. And you get a 10R cube. Bring the 10R minus 10R. Sorry, minus 20R. Right? So minus 20R equals 0. And you take an R. You can divide by a 10 for sure. And you take an R out. You get R square minus 2 equals 0. So R can take values of 0, root 2 and minus root 2, right? 0, root 2 and minus root 2 over here. C equals how much over here? C equals how much? Given that we have the value of a R, you can just plug into one of them, right? Let's say the first one, R is root 2, right? So you're going to get 5 into root 2 whole cube, which is 10 root 2. 5 into 2 root 2. Root 2 whole cube is 2 root 2 plus root 2 whole square, which is 2c, minus 10 into root 2 plus 9 equals 0. These get cancelled. C equals minus 9 by 2. Option 1 over here is the answer. Okay, the last concept here, maximum and minimum of quadratic graph concept and formula, how it looks and how it works. Something like this, right? This is the minimum value it's going to attain. And that's going to be at x equals minus b by 2a. And if I want the output over there, that's a direct value over there is f of x equals 4ac minus b square by 4a, right? If you want a direct value, or you find the x value and substitute back into the expression and you will get that, right? Either way, if you remember it, well and good. In some places it comes in handy, 4ac minus b square by 4a, right? So that's the formula for these two. It's the same when it comes to inverted U shape as well. The maximum point is going to be at x equals minus b by 2a. And the output at that point is going to be 4ac minus b square whole divided by 4a. Now, what is the formula for sum of roots? It's nothing but minus b by a, right? Why is the sum of roots minus b by a? Because from this minimum point or maximum point, one of the roots is going to be minus b by 2a plus a k. The other root's going to be a minus b by 2a minus k. If you add these two, the k's get cancelled. You add up these two, you get a minus b by a sum of roots. It's all with this minimum point over here, right? X equals minus b by 2a. So let's look at an example, right? So where we can possibly apply that. The minimum possible value of the sum of the squares of the roots of the equation. Alpha square plus beta square is the sum of the squares. So I have to minimize this as much as I can, right? I have to minimize this as much as I can. And I have a plus 3 and minus of a plus 5 over here, right? So for me to minimize this, I can write this as alpha plus beta the whole square minus 2 alpha beta, right? Minus 2 into alpha beta. And what is alpha plus beta over here? The sum of roots. Alpha plus beta equals minus of b by a, right? Which is a plus 3 by 1. Alpha beta, the product of roots is c by a minus of a plus 5. Alpha plus beta minus of a plus 3 the whole square, minus gets taken care of. I'm getting a plus 3 whole square minus minus 2 into minus of this is a plus 2 into a plus 5. And that's it. What am I going to get here? A square plus 2 into 3 into a, 6a. 6a plus 2a is 8a. Then plus 9 plus 10 is plus 19, right? That is what we're getting over here. A square plus 8a plus 19. That is going to be the sum of the squares of this. And this over here has to be minimized as much as possible, right? 4ac minus b square by 4a, right? We can just directly plug in. That's going to be the minimum value of this expression. 4 into a into c into 1 into 19, 4ac minus b square, 8 square divided by 4 into 1, right? So this step, what we're going to be getting is 76 minus 64, right? Earlier we had written it as 8, right? So it's 76 minus 64, 12 by 4, which comes to 3, right? Option 3 over here is the answer. And in case you want to, right, a equals minus 8 by 2, minus 8 by 2, which comes to minus 4. That minus 4, if you plug in over here, you're going to get 16 minus 32 plus 19. 35 minus 32 will also come to 3, right? Both will give you the same answer. 3 is the answer here. 28th question over here is actually a very conceptual question. What does it say? If r is a constant such that modulus of x square minus 4x minus 13 equals r, okay, has exactly 3 distinct real roots, fine. Wait, exactly 3 distinct real roots, fine. Then the value of r is going to be what? So 3 distinct real modulus of something is equal to r, right? Let me rewrite this as modulus of x square minus 4x minus 13 minus r equals 0. So this, let's work with, one step at a time. This quadratic expression x square minus 4x minus 13 could be like this, right? X square minus 4x minus 13. But if I apply a modulus to it, modulus of x square minus 4x minus 13, whatever is negative has to become positive. So it's going to be like this, and it's going to be like this, and it's going to be like this. Now, when I pull it down by r, when I subtract an r from it, it should have exactly 3 distinct real roots. It can't be 4, which means it can't be like this, then it's 4, which means I have to keep pulling it down till I reach that point wherein just this tip is going to touch it over there. So it's going to be like this. It's going to be like this. And it's going to go up again, right? It's going to go up again. So this point over here, it has to be pulled down by that much. It's going to be pulled down by that much. How much should it be pulled down by? If I have to be pulled down by that much, right? If this value over here is r, this value over here should have been minus r, right? Only then it got flipped over there and got r, became r. So essentially, I need to find out the minimum possible value, right? That's it. That's about it, right? That's the r by which I have to pull it down. What is going to be 4ac minus b square by 4a, right? 4 into a into c, which is coming to minus 52 minus b square, which is 16, divided by 4. Minus 52 minus 16 is minus 68. Minus 68 by 4 is coming to minus 17 over here. So if minus r over here is minus 17, r should be equal to 17. Option 2, we can mark it and keep going. Again, we can apply that concept over here, provided we conceptually understand. In case that 4ac minus b square by 4a is not exactly clicking over there, then you can find the value, the minimum point over there. What's the minimum going to be? At x equals minus b by 2a. Minus of minus 4 is 4 by 2, which comes to 2. When you substitute x equals 2, what are you getting over here? 4 minus 8 minus 13, which comes to minus 17. Now that minus 17 was the minus r value, it becomes a plus r, so it becomes plus 17, which is what you have to pull by.